Question 3, this is a question trying to get us to work out which t statistic or z statistic we're going to use. So it's a very similar to the last few questions where we've been trying to work out which scenario we fall in. So let's have a look. We're given a random sample size 40, n equals 40. It's a non-normal population and we do know the mean, but we don't know the standard deviation. And we're going to conduct a t-test of the hypothesis. Mu is equal to 55 is the null hypothesis, and mu is not equal to 55 is the alternate hypothesis. And note that this means we've got a two-tailed test. So the first thing we're going to say is, are we going to use a z or a t-test? Well, you might recall from the last video we talked about non-normal distributions with unknown standard deviations. Well, if the sample size gets high enough, the approximation of using a z statistic is quite accurate. Can be as high as much of an error as 5%, but not too bad. But if we use a t statistic, we can get a more conservative and a more accurate reading. So what we're going to do is you take a t statistic with n-1 or 39 degrees of freedom. So let's have another look. So we've got n is equal to, so we've got degrees of freedom is equal to 39. We know mu is equal to 55. That doesn't matter, but what we do need to know is that it's two-sided. So it's two-sided. We know alpha is equal to 0.05, which is given here. And that's pretty much all we need to know. So because it's two-sided, we know that it's going to be that t could actually be less than the negative value or greater than the positive value, which is the absolute value. So I'm going to wipe out a and b straight away. And let's put these actual ones into our table and see what we come up with. So we need 39 degrees of freedom. The table I'm looking at, which is the first one in the exam table sheet, actually gives us values for alpha divided by 2. So I can straight away look up the 0.05 alpha column, go down to degrees of freedom 39, and I can see that the value is 2.023. So it looks like C is going to be the correct one. So let's just see if we can work out what some of these other wrong answers were and why we might think that. So D, 1.96. So we're looking for alpha, the t value greater than 1.96 or less than negative 1.96. If we have a look where that comes from, it looks like that is the value if you're using a z statistic or using an infinite degrees of freedom t statistic. So it's z of alpha divided by 2 for 0.05 alpha is 1.96. So this would be true if it was a normal population and we knew the standard deviation of the population, not of the sample. What about this one, 1.685? So that looks like the degrees of freedom for, it's quite a tricky one actually, because that's the value next to 2.023 in the table, so that would indicate an alpha of 0.1. So you had to recognize in the table we're given alpha divided by 2 values, so you didn't have to, well actually, if you divided it you'd get 0.025, so this is actually going even a step further to say, yeah, this is alpha of 0.1, and if you thought you had to split it, then you'd get 0.05. Yeah, I guess easier mistake to make. Right, so we know it's not that. What's 1.645? Well, that's the z value again for an alpha of 0.1. So it's the wrong alpha and the wrong statistic. So we'll go with our answer of C, which is the correct region is that the t statistic has an absolute value greater than 2.023.